Hello student, welcome to my channel Kunal sir at JEE NEET Chemistry World. So today I am going to discuss exclusive model question answer for upcoming JEE Advance 2025, and this is a extreme model of JEE Advance based on ionic equilibrium, and that's particularly subtopic is solubility, and in that solubility there are sparingly soluble salt or insoluble salt. Based on that problem is chosen. So now here the problem they are giving, AgCN, which is sparingly soluble salt, has a KSP of 10 power of minus 16. Find out the solubility first in pure water and then in buffer solutions where the pH of buffer solution is 3, maintaining consistently. So now this is a very famous model, an extreme model of JEE Advance, and based on that reverse problem also we will discuss. You will see how the problem extremities. Most of the website if you look at, most of the book if you look at, the way they are approaching to this type of model JEE Advance problem is extremely difficult to understood. But now I am explaining that problem very elegant manner, efficient manner, moreover easily grasping manner, which will enrich your knowledge as well as give a directions towards the cracking JEE Advance. Now if you look at first problem, that means first part of a problem, it's very easy. So now AgCN, if I say AgCN solubility in pure water is S moles per liter. Then KSP expressions, I hope you know how to find out the KSP expression. AgCN is in equilibrium, which is a dissolved, and is in equilibrium with a corresponding ion, which is a dissolved but undissociate, that will be in equilibrium, which is a dissociate part. And now if the solubility is S, then S mole will give S mole of silver and S mole of cyanide ion. Then the KSP expression will be equals to Ag plus ion raised to the power of their stoichiometric coefficient into cyanide ion concentrations raised to the power of the stoichiometric coefficient, which is nothing but a S into S, which is nothing but a S square, where S is a solubility. And now KSP expression of AgCN is S square, and KSP value they are giving 10 power of minus 16. Then I can write down S square equals to 10 power of minus 16 in pure water. Pure water pH, you know, everybody's pure water pH is 7 at 25 degrees centigrade. Everybody know these things. Then S square equals to 10 power of minus 16. S equals to under root of 10 power of minus 16, which is equals to 10 power of minus 8 moles per liter. So that is the solubility of AgCN in pure water. In pure water there is a no problem, directly we can find out that one. The problem arises in buffer solutions of pH equals to 3 they are telling, and K for HCN data they are provided. K is a dissociation constant for the weak acid. This HCN is nothing but a weak acid. So for that dissociation constant they provided 10 power of minus 10. So that means whenever pH is decreases, then H plus concentrations will be increases. Fundamental things is what? If you look at pH 7, that means for in pure water at 25 degrees centigrade, pH 7 means H plus concentrations will be equals to H minus concentration, which is nothing but a 10 power of minus 7 moles per liter. But when they are pH 3 means my H plus concentrations will be equals to 10 power of minus 3 moles per liter. Whereas my H plus concentration, if you look at my H plus concentration increases in a solution, then obviously OH minus concentration has to be decreases, because H plus concentration into OH minus concentrations, they always will be equals to 10 power of minus 14. So that's why if H plus concentration increases, OH minus decreases, so that overall value there should be 10 power of minus 14. So now that idea always you have to keep in mind, and whenever we know everybody H plus concentrations will be, if it is increases, then OH minus concentrations of solution decreases, of solution it will be decreases, and always H plus concentration into OH minus concentration, which always will be equals to 10 power of minus 14 for any solution. That's why pH plus pOH equals to 14, because we know H plus concentrations minus log of base 10 H plus concentration equals to pH. We know this thing. That means H plus and pH are inversely proportional. If my H plus concentration increases, then pH of the solutions has to be decreases. This is the fundamental idea of ionic equilibrium. So now if you look at the next part of the problem, what is going to happen in buffer solution of pH 3? That means pH 3 means compared to the pure water pH was there, they didn't mention, but we know at pure water 25 degrees centigrade pH is 7. That means pH of the solution decreases. That means my H plus concentration increases. Definitely what is going to happen, if you look at cyanide ion is there, cyanide ion, they will undergo some reaction with a H plus, they will form the HCN. Then HCN, some part will be dissociate and some part will be there in the form of a HCN, because it's a weak acid. Then whenever cyanide is reacting H plus, cyanide concentration is decreases. That's why equilibrium will shift forward direction. Then we can understood solubility of AgCN, this has to be increased in pH 3. That is the point we understood clearly as per the equilibrium concept. If you look at, they are in maintaining equilibrium. If product concentration decreases, reaction will proceed towards the product. That's why towards product going means solubility is what? Increases. Solubility means from the dissolved salt how much amount of the corresponding ion is giving, and that ion is surrounded by water molecule, which is the aqueous form. So that's why if you look at, as cyanide is going a side reaction, then obviously cyanide ion concentration is decreasing. Ksp is a equilibrium constant for this reaction. So that's why Ksp is a constant. So that's why if you look at, to maintain the constancy of Ksp, more and more reaction will go to the forward direction, so that Ksp value should be a constant. That means equilibrium constant for this equilibrium will be a constant. So that's why the solubility will be forward direction going, means more ion come into the solution, solubility will be what? Increases compared to the pure water. That is first part we understood. Now let us look at in this problem how we will approach. If you look at this problem, then I am telling, in buffer solution of pH 3 means H plus concentrations will be equals to 10 power of minus pH, which is nothing but a 10 power of minus 3 moles per liter. So then obviously in buffer solutions of pH 3, I am telling solubility of AgCN, I am taking, which is a S1, new solubility in buffer solution of pH 3. Then immediately now I can write down AgCN will be like that situation. AgCN will be dissociated into silver ion plus cyanide ion. Now if the solubility is S1, silver ion will be S1, but cyanide ion will not be, cyanide ion will not equals to S1, because it will undergo some side reaction. Exactly how much cyanide ion concentration, That is I'm going to find out based on the whatever data they provided. Now, if you look at, then I am telling cyanide ion concentration, it should be as per our logic, it should be S1. But some cyanide will undergo some side reaction. So that's why it will not be exactly S1, which is exactly it is, we will find out that one. Now I am telling S1 equals to some cyanide ion which will be there in the free and some cyanide will form a HCN. That I can write down. You look at, I write down S1 means cyanide ion concentration will be equal to some cyanide free and some will be react with a, because these will undergo react with a H plus and it will form a HCN. HCN will, some amount will be dissociate, that means some amount will be dissociate and some amount will be there in the form of HCN. That means ultimately cyanide will be there, some free form and some in the form of a HCN. Now for the HCN, what I can write down, whenever HCN is dissociating like this, I can write down Ka will be equals to active mass or molar concentration of the product raised to the power of their stoichiometric coefficient by active mass or molar concentrations of reactant raised to the power of their stoichiometric coefficient. Now Ka value they provided, have you looked that problem? You look at in the Ka value, previous slide already it is there. The Ka value of HCN they provided, which is nothing but a 10 power of minus 10. So that Ka value, look at here, Ka for HCN is 10 power of minus 10, which is they provided, pH is 3. Then if you look at these things, we are going to solve the problem in a second slide. So Ka will be equals to H plus concentration is nothing but a 10 power of minus 3. So Ka is 10 power of minus 10. H plus concentration is 10 power of minus 3 and which is cyanide ion concentration by HCN. Then HCN will be equals to concentration of HCN or molarity, which will be equals to 10 power of minus 3 into cyanide ion concentration by 10 power of minus 10, which will be equals to 10 power of 7 into cyanide ion concentration. So look at HCN concentration is equals to, then instead of HCN, I can write down 10 power of 7 into cyanide ion concentration. So that means if you look at next reverse problem will give you more difficulty. That's why I can write down that HCN equals to some A into cyanide ion concentration. Yes or no? Because 10 power, and I am telling A equals to 10 power of 7. That value of A is nothing but a 10 power of 7. Now, if you look at over here, then S1 equals to cyanide ion concentrations into, instead of HCN, what I can write down? 10 power of 7 into cyanide ion concentrations. If I take cyanide ion concentration common, then what I can write down? 1 plus 10 power of 7. Now, which will be equals to S1. With respect to the 10 power of 7, 1 is negligible, neglecting 1, neglect. And then immediately what you are getting, S1 equals to 10 power of 7 into cyanide ion concentration. So 10 power of 7 we already know, again or that way I can write down S1 equals to A into cyanide ion concentration. Why? Because I told the A value is nothing but a 10 power of 7, because next problem it will come into the work. So that's why I write down. Then cyanide ion concentrations will be equals to S1 by 10 power of 7. So now that's why I told that cyanide is not exactly S1, which is nothing but a S1 by 10 power of 7. So now you look at Ksp is not going to change. Ksp already we find out 10 power of minus 8 in pure water. That value will be there, whatever may be the buffer solution. Ksp is a constant, it's a equilibrium constant, it's not going to change. So then immediately Ksp will be equals to, Ksp of AgCN will be equals to, for silver ion concentration into cyanide ion concentrations. Silver ion concentration S1 into cyanide ion concentration, instead of cyanide ion, what I will write down? S1 by 10 power of 7. already we know KSV value, they provided KSV value 10 power of minus 16. So that's why 10 power of minus 16 will be equals to S1 into S1 by 10 power of 7, or then S1 square will be equals to 10 power of minus 16 into 10 power of 7, which is gives rise to S1 will be equals to under root of 10 power of minus 9, which is nothing but a 10 power of minus 9. I can write down 10 into 10 power of minus 10. So under root of 10 means 3.2 into 10 power of minus 5. These will be your new solubility in buffer solution. But in pure water it was there 10 power of minus 8. But here it is there how much? 10 power of minus 5. Before solving itself, I told you solubility has to be increased because the corresponding anion is undergoing side reaction. Same way, if cation is undergoing side reaction, solubility has to be increased. Same methodology you can follow and you can solve the same model problem. So now my answer will be in a buffer solution. Answer will be solubility 3.2 into 10 power of minus 5. Now, you people understood this problem. This is a JEE advanced model. Now, they make it more extreme way that problem. And how can I solve that problem? Very interesting way they asked. Look at that one. So, in that just now we solved that problem. They are asking that problem in a reverse directions. So, that's why advanced. There is a 2-3 things will be mixing, and you are comfortable in forward direction, backward direction, half direction, any direction of the concept you should have a master. Basic thing is that same thing, JEE and NEET. Based on that 2-3 things will be mixing. JEE advanced is not only its intelligence checking, but also several factors will be changed. Checking will be there for yourself. There will be intelligence checking will be there. How you are handling the time, how you are smart enough to solve the problem, how you able to solve the different complexity of problem. Everything will be check up, and then only JEE advanced. JEE advanced, my dear, it's for IIT. Yes or no? So now that's why you look at the same model problem, how fantastic way they ask in the reverse way. As far as many videos I discussed, myself is Dr. Kunal Das. I have more than 15 years experience from explaining this JEE advance, and I worked several reputed organizations like Akash, Alliance, Chaitanya, Narayana, all these organizations I worked out and I solved the problem. My students are benefited and they are well established in very renowned IIT and very renowned computer science batch. So now, if you look at the same model problem, they ask in a very reverse way. Then here how we will solve. They told solubility of AgCN increases 10 power of minus 4 moles per liter. Moles, this will be moles per liter, to 10 power of minus 3 moles per liter when pH changes 7 to 2. And then they are asking find out the pK of AgCN. pK is nothing but the same thing. If you know the K, then pK will be equals to minus log of K. That's all it is. Yes or no? Base 10. If you are able to take the Ka value, x into 10 power of minus y form, then your pK will be equals to y minus log x. Directly you can write down like this way. Yes or no? Now you look at forward problem we just solved it. Now backward problem, how can we solve that one? Now, if you look at solubility is increases, that means whenever my pH 7 means it's a pure water. Pure water solubility means S equals to, S is a solubility. Solubility will be equals to 10 power of minus 4 moles per liter. And just now we did it, AgCN, if the solubility is S, then it will be Ag plus Cn minus. These also SS, KSP expressions will be equals to silver ion concentration into cyanide ion concentration, which will be equals to S into S, which is nothing but S square. And then S is 10 power of minus 4 at pH 7. So then Ksp will be equals to 10 power of minus 4 into 10 power of minus 4, which is nothing but a 10 power of minus 8. And this Ksp value not going to change even though the pH is going to change, because it's nothing but what? Equilibrium constant. That's why name itself is a constant. So now, how we can solve this problem? Backward directions. Now, we know that just now I solve it. In the final expressions, what I write down? Suppose I am telling whenever pH 2, then H plus concentration equals to 10 power of minus pH, which is 10 power of minus 2. And that time, my solubility, if it is S1, so then immediately I can write down S1 into, for cyanide ion, what I did? S, because cyanide ion will form only HCN, S1 by 10 power of 7, 10 power of 7, which is nothing but A. So then S1 into S1 by A, which will be equals to Ksp value. Ksp value is nothing but a 10 power of minus 8. Then immediately what I can write down? This is representing your silver ion concentration, and this S1 by A representing is nothing but a cyanide ion concentration. Because A, that time we did it same way, S1 by 10 power of 7, and I told A equals to 10 power of 7. But here we don't know what is the value of A. That problem was there. That's why I used to give that way indications. But here A value will be different. That's why you look at here what I will do it over here itself. Then immediately what I can write down? S1 square by A equals to 10 power of minus 8. And here your S1 equals to 10 power of minus 3. When pH is 2, your solubility increases from 10 power of minus 4 to 10 power of minus 3. Here your S1 equals to 10 power of minus 3. So then immediately 10 power of minus 3 whole square by A equals to 10 power of minus 8. So then A will be equals to 10 power of 2. Because 10 power of 6 and denominator will be 10 power of minus 8. If you take up, it will be 10 power of plus 8 and 10 power of minus 6, which is nothing but these things. And again, have you noticed that one? HCN equals to, ultimately what I write down? 10 power of 7 into cyanide ion concentration, which is nothing but A into cyanide ion concentration. And A equals to, we got it how much? A equals to, we got it 10 power of 2. So then immediately HCN concentration equals to 10 power of 2 into cyanide ion concentration. Now, whenever HCN will be dissociated, it will be dissociated like this way. H plus plus cyanide ion. H plus plus cyanide ion. You look at HCN will be dissociated. For this reaction, Ka will be equals to H plus concentration into cyanide ion concentration by HCN concentration. Now these things I am writing over here, you look at. Then H plus means pH is 2. So then H plus is 10 power of minus 2. Then K will be equals to, H plus concentrations will be equals to 10 power of minus 2. pH is 2. 10 power of minus 2 into cyanide ion concentrations by HCN concentrations. HCN concentration is nothing but A into cyanide ion concentration, which is nothing but 10 power of 2 into cyanide ion concentration. So then 10 power of 2 into cyanide ion concentration. Then cyanide ion cancel out. Then K equals to 10 power of minus 2 and into this 10 power of 2, if you take in a numerator, this also will be 10 power of minus 2. So then immediately is equals to 10 power of minus 4. So then you look at here, K is coming out 10 power of minus 4. Pk equals to minus log K. That means I can write down these things equals to K equals to 1 into 10 power of minus 4. And then I told you K, if you able to take x into 10 power of minus y. So then Pk will be equals to y minus log x. That means 4 minus log 1. Log 1 value is 0. So that's why directly your Pk will be equals to nothing but how much? 4. So that's why you look at the option was there. First option was there 2. Second option was there 4. Third option was there 1. Fourth option was there 5. So that's why second option is matching, because they are asking Pk of HCN into the problem. Now again I am briefing how we did. So now in pure water, that means when pH is 7, solubility if it is a S, then S equals to value is this 10 power of minus 4 means it is S solubility. So then at that time S square will be equals to your KSP expression. So that's why KSP is nothing but a 10 power of minus 8, a 10 power of 4 into 10 power of 4, which is S square, 10 power of minus 8. Now this KSP is not going to change whenever pH of the solution is 2 itself also, because it's a equilibrium constant for the same set of salt. And now that time I told you when pH is 2, H plus concentration 10 power of minus 2, solubility is S1. And finally previous problem, same forward problem we did it, silver ion concentration, new solubility S1 means silver ion into cyanide ion. Cyanide is not exactly S1 by something, that's why S1 into S1 by A, and I am telling I don't know the A value over here. Forward problem A value was there 10 power of 7, but in backward or reverse problem A value we need to find out, and that's why S1 into S1 by A equals to 10 power of minus 8, because 10 power of minus 8 is a KSP. KSP is not going to change whatever may be the pH of the solution. So then which is nothing but a 10 power of minus 8. Now from there, and S1 equals to new solubility, which is nothing but a 10 power of minus 3. So that's why S square equals to 10 power of minus 6. So then that's why A will be equals to coming 10 power of 2. 10 power of minus 6 by 10 power of minus 8, which is nothing but a 10 power of 2. Now once we got the A value, then HCN concentration forward problem we observe, which was there. We have a expression S1 equals to cyanide plus 10 power of 7 into cyanide, or A into cyanide and concentration, and A into cyanide and concentration, instead of HCN we put that value. So that's why HCN equals to A into cyanide and concentration. Here A we calculated, which is nothing but a 10 power of 2. Yes or no? So then immediately once we put this HCN concentration, then whenever HCN will dissociate, H plus plus cyanide and concentration, and then immediately K will be equals to, you look at H plus into cyanide ion concentration by HCN concentration. H plus means pH was 2, H plus concentration 10 power of minus 2. Cyanide ion concentration by, instead of HCN we put 10 power of 2 into cyanide ion concentration. Here I put, you look at, and then cyanide and cancel out, then K will be equals to 10 power of minus 4, pK will be equals to 4. Yes or no? That's why our answer is the second option. That only they ask, find out the pK of HCN. I hope everybody understood the problem with a full clarity. To get this type of more JEE advanced problem, come and comment in my channel, and your valuable comment will make me to give exact JEE advanced model problem and extreme JEE advanced model problem. I hope everybody understood. Everybody will utilize this one for upcoming JEE advanced on 18 May. Thank you very much. Thank you all.